Okay, so your challenge here is to graph the polar equation in the easiest way. So if you were to graph that, how would you do that? So you can get out some polar coordinate paper and try that. So you can pause the video and try to graph it. Okay, welcome back. So what I'm thinking is you tried to plug in some angles, right? And then figure out what the radius is, plot those points, and start trying to graph. That is not exactly the easiest way. We're going to come back to this in a second. One thing is sometimes it's easier to convert from rectangular to polar or vice versa. Just like with points, we can convert equations. So I want you to recall when we converted points from polar to rectangular, we used these two equations. These are going to be important. We're going to use these again, but now we can convert equations. So this says convert this equation from rectangular to polar. So instead of y, I can substitute what y is equal to. So y is equal to r sine theta. So right here, I'm going to put in r sine theta. Okay, and then on this side, I have 3 times x plus 2, so just for the x, it'll be 3 times whatever x is. Well, x is equal to r cosine theta. So I'm going to say equals 3 times r times cosine of theta, and then plus 2. So now that's a polar equation, and it will be the same graph. So now we like to solve these for r. So here's what I'm going to do. We like to write our polar equations r equals if we can. So we're going to take any terms that have r in them, which happens to be this term, r sine theta, and this term here, 3r cosine theta. Any terms with r's, and we're going to get them on the same side. So I'm going to subtract 3r cosine theta from both sides. So now this will be r sine, oh, now it's wigging out. It was working so nicely. R sine of theta minus 3r cosine of theta. All right, so since we can't, one's sine and one's cosine, we can't subtract them, we just keep track. Over here, they cancel out and equals 2. The reason I got the r's by themselves on one side, all the terms with r, is now, whoops. Now that r shows up in both terms, I can common factor out that r. And then to solve for r finally, I divide both sides by sine of theta minus 3 cosine of theta. So over here they cancel. We got r equals 2 over sine of theta minus 3 cosine of theta. That is the polar version of this rectangular version. So we know that that y equals 3x plus 2 looks like a line. So let's graph the polar version and see what we have here. There it is. All right, so we're talking about 2 divided by, and it was sine of theta, sine of theta minus 3 cosine of theta. All right, so now we can take a look at what this looks like. We know it was supposed to be the line 3x plus 2. So let's see when we graph it. There it is. There's our line 3x plus 2. That has a slope of 3 and a y-intercept of 2. All right. Miss Fallon doesn't want to be in our video, apparently. Next time? All right. So there you can see that we have the same equation. So we just converted it. Now we're going to go from polar to rectangular. So we are going to use the same idea here. Let me get a full screen for us. We're going to work with the idea that x equals r cosine of theta and y equals r times sine of theta. So we're going to distribute that r. So r sine theta plus 2r cosine of theta equals 1. So I just distributed this r to both terms. Now I know that r cosine or r sine theta is equal to y. So I can put a y in there. Plus 2 times r cosine theta. So r cosine theta, whoops, I didn't want to do that. I wanted to use the highlighter. R cosine of theta, right here, is equal to x. So I can put x in its place. All right, so we can leave it like this. That's rectangular. But if you want, you could solve for y. Again, that would be a line. And if we graphed this thing in the polar, we'd see it's the line y equals negative 2x plus 1. So now try your challenge again. All right, so see if you can apply these concepts to the challenge question. So I would rather just graph a line if I could, instead of trying to figure out this polar. So see if you can convert this to rectangular, and then you'll have a graph. I'm in the hallway because I have a study hall, but we can hear you, Miss M. Talking about signs and negative signs. All right, so anyway, pause the video and see if you can change that to rectangular. Okay, welcome back. So you should have gotten x plus y equals 2, or you could write it as y equals negative x plus 2. If you have questions, you could ask me that in class. So now I could graph that much more easily. It's easy to graph that line. Instead of trying to pick, I keep moving and coming back. Instead of trying to pick angles here, plugging them in or whatever. All right, let's do one more. Convert this equation from polar to rectangular. So r squared cosine squared, I can write that as r, oh, come on, pen, just make it through like one more minute. R times cosine of theta, oh no. All right, I guess I gotta write it more slowly. R times cosine of theta squared minus r sine of theta equals negative 2. Now I can use those identities again. R cosine of theta is x, so it's x squared. R sine theta is y. So there's our rectangular. And again, if I wanted to graph it, it's easier to solve it for y. So I add y, I add 2, and this would be the same thing. It's going to be this parabola shifted up 2.